Howdy folks. Howdy folks. Today we got this beautiful old Marshall JTM 30 on the test bench. We're going to be replacing filter caps because the amp's got a slight issue where it comes to clean headroom and noise. And what we're also going to do is replace the tubes. Now that's going to come later because I haven't ordered those parts yet. However, what we're also going to do is replace the broken volume socket, or volume pot here, sorry. And I've got a new knob coming too. So what I'm going to do now is essentially unsolder the 47 microfarad filter cap and this 1, 2, 3, 4, 5 22 microfarad filter caps, remove them from the chassis and replace them with better quality ones. Now the ones on here are Nishikon, so they're pretty good quality actually, to be honest. I take that back. Nishikon's a pretty good brand when it comes to radial caps like this. If this had normal axial filter caps like you find in older tube amps, then I would probably go with Sprague or F&T. But I'm going to go with Nishikons as well. I'm going to go with the brown ones because these ones in here are only rated to 85 degrees. And some of them, you can't really see in through the camera, but some of them are swollen down the bottom. Especially this one right up here. The bottom of it's actually completely shat itself. So we're going to replace all of them because why wouldn't you? Now the good news is with this, even though it's all circuit boards, I don't need to rip it all out. The bad news is I'm going to have to anyway because I'm going to have to get to this volume pot right in here. And the only way to do that is to remove this. And you can see the clearance between this circuit board here and this one is not enough to pull this out to clear the pots from the chassis and remove this. So the only way to do this is I'm gonna have to remove this anyway, which means pretty much just to replace one pot I'm gonna have to disassemble almost the entire amp bar this output socket here. Okay, the speaker output socket. So the next time you see this in a couple of seconds, I will have replaced these capacitors, and what I will do is remove this circuit board and this circuit board, replace the volume pot, put a new knob on there, and this amp will be ready to go. However, we are also going to change the power tubes and the preamp tubes. The preamp tubes in here are the original Marshall branded ones, but they've been in here since 1997 when the amp was made. The owner of this has owned it since 1999, I believe, which means he has never replaced the tubes. So changing the tubes alone, the amp is going to sound amazing. Now these are cathode biased, but they're biased in such a way, my understanding is that they're biased using diodes as voltage droppers for the negative bias, or the cathode bias, I should say. I am going to have to research to find out how to change this to a fixed adjustable bias or something like that. Now there is a whopping great big resistor here, and it is a 5 watt 470 ohm resistor. That kind of looks like a bias resistor to me. I think once I replace the caps and do all the other work, I may just have a sticky beak around and see what this needs to be an adjustable fixed bias. So in the meantime, I'm going to sit here and pull these old caps out, and I'm going to show you what that looks like when I'm done, and then we will cut to the next part where you'll see me with brand new Nishikon 105 degree filter caps, which are rated at a higher temperature than these 85 degree ones for starters, and secondly they are also rated, the ones I'm getting are rated for 20,000 hours. So I'm spending a little bit more money on this, buying very high quality capacitors. Let's get started with the capacitor removal. So these are our old Nishikons here. There's 5 22 microfarad 450 volt caps, and the big one here is a 47 450. I've ordered the replacements for these now, and we're going to go ahead and wait for them to arrive. And once they do, we will replace them and carry on with the next part of our repair, which is fixing up the volume pot that's hiding back there. So at this stage, I'm going to take a break and go work on some other amps, which I'm also recording, and we'll continue this in a moment. Alright folks, so the saga continues with this Marshall JTM 30. In actual fact, there is nothing wrong with the amp at all, now that I've completed all the minor repairs that needed doing. So basically I'm just going to do a quick run through. It's actually been sitting on my bench for about a month, and the reason for that, unfortunately, is because a courier company, which I am going to name and shame, Fastway Couriers, anything but fast. And they don't even know the way to do their job. So they are ironically named because we spent about a month trying to track a parcel that they had lost. A parcel that contained the parts that I needed to complete this job. Also, brand new Sovtek 5881s. These are the ones with the very short base on the bottom, the ones that, you know, the couple of millimeters long in the base. And the reason for that is simple. Anyone who uses these amps or knows about them knows that the valves, the 2 power valves in here, you can't put regular 6L6s. You can't even put regular 5881, what are the Sovtek's, WXTs, I think. They're too long. So then you go to put the cage on, and they stick out. So what I've done is, I've got the volume pod in here, okay, sitting up here. The PCB's been mounted back into the chassis, and new filter caps here, all put in place, all higher rating than what was in there. So the same value, the same microfarads, just a higher rating. I'm going to check the bias on them anyway, you know, turn the amp on. Before I do any of that, I'm also going to recheck my work of the caps, the filter caps that I put in here, make sure I've orientated them the right way. It looks like I have, but you know what? Double check, because if you don't, things go up in smoke, and then the customer is then still waiting for their amplifier. So I'm going to go ahead and do that right now. Replace the valves, turn things on, and let's see what happens. I'll get the oscilloscope up and running as well. We'll check the waveform on the clean and dirty channel, make sure it's working right and doing the right thing, and then we'll pop the amp back into its cabinet and do a soak test for a couple of hours. So stay tuned for more of that. Alright, so a little bit of bad news with this amplifier. I got it all back together, I put the new tubes in. I thought, oh shit. So I turned everything off. What I found was that they were red plating. So I've done a little measurement here. Pin 3, which is our, so V4 and V5 are our 5881 tubes. Pin 3 is our plate. We're getting 508 volts on one side and 507 on the other side. That's about on par, considering they're being fed off the output transformer. So it's possible that the output transformer resistance is slightly different on either side. Grid 2, which is pin 4, we're getting 505 volts, and on that one 504, so 1 volt down. That sounds about right. And in grid 1, which is pin 5, we're getting minus 28 volts on both of those sides. I'm suspecting with the plate voltage this high, this number should be a little bit higher. With this amp, I looked at the circuit, and let me see if I can shed some light on this matter. No, I can't. Sorry about the darkness, but behind this resistor and capacitor, or kind of in between them really, let me get my... Okay, that might be a little bit nicer to work with. So there's a Schottky diode here, or Zener Diode, sorry, and then another Zener Diode under here, and then one more back here. And the one back here is a 15 volt, this one's a 15 volt, and this one's a 9 volt. So it's ZD 101, 102, and 103 on the schematic, and they're identified here correctly on the circuit board. So each one of these, the ones at the back here, are 15 volt, and the one at the front's 9. So you got 15 and 15, which is 30 volts, and then the 9, which is 39 volts. So technically the bias, this is controlling the bias. So they're not using resistors to control the bias. They're using diodes to give you the negative voltage. There's actually another diode tucked away in here. Let's see if I can find that. Just in here. Okay. That diode there is, I believe, diode 107. So that's giving us our reverse polarity, which is giving us our negative bias. The diode back here is in charge of our negative bias. However, these three diodes here are setting the voltage of that. And it should be 39, according to mathematics. 15 plus 15 is 30. 30 plus 9 is 39. I'm measuring 28. So we need to increase that bias voltage for these tubes to stop red plating. Alright, so the Marshall JTM 30 episode continues. This has been a couple of months in the making, waiting for parts and bits and pieces, and to be honest, one of the final pieces of the puzzle has been trying to get this amp working without going into red plating. Before I put tubes in, I ran this up slowly on a variac. I then also measured voltages, measured bias. Everything was fine. Everything was going okay. I measured voltages, and obviously, you know, with no tubes in there, there's going to be a voltage increase. But I was playing it on the safe side. My good friends over at Evatco generally look after me, and they have in the past, and they always will, and they always do. I didn't mention that the tube was faulty from the get-go. I said to them that the tube has become faulty. I don't want a replacement, I just ordered a new set. Now, what I found was there's 5881s and then there's 5881s. There's ones you can get, like the ones that the customer supplied inside the amp. Okay, these ones, 5881WXT, which are basically 6L6s with a lower plate dissipation, lower wattage. Okay, these are big tubes though, and they don't fit in this amp. What I've put in here now, through careful measuring, I found a pair of Tung-Sols. Now, I'm a fan of these tubes. I like Tung-Sols. My Fender Bassman 50 is running Tung-Sols through the entire amp. I've got the Tung-Sols already installed, so I'll see if I can show you. There they are in there. You can see they've got the big sort of dark brown bass in there. And the original 5881s that came in this were the little wafer bass here. Okay. And the ones I replaced them with were the wafer base ones. In fact, the one I just showed you in my hand is the replacement one that's faulty. So my fear of getting the Tung-Sols was they weren't going to fit, because you see a picture online, you don't know how tall it is. You look at data sheets, some of these data sheets are so old and haggard, it's really hard to tell if the tube is going to physically fit in there or not. Luckily, the good friends I have at Evatco helped me out. I sent an email to Kevin over there in sales. Well, I think he's the owner of the company, actually. And I said, hey, matey, can you tell me the height of these tubes? Not only did he give me the measurement of the height, he gave me the measurements from the pins to the top of the glass. He gave me the measurements from the bottom of the base, where the pins come out, to the top of the glass, and the width as well. Okay, so I had all the information I needed to make sure these tubes were going to fit, and as soon as I got that email, I went onto his website and ordered them. And as luck would have it, they're not only small, they're smaller than the original 5881s with the wafer bases. So they fit beautifully. And the other good news is, not only do they fit beautifully, they're not red plating, they're not arcing, they're not doing anything silly. They popped in. I'm going to check the bias. Now the reason I'm going to check the bias is this. Now here in this section right here of the circuit board, which is right near the power supply, there's your main transformer, and here's your two first main filter caps. 47 microfarad 450 volt, 22 microfarad 450 volt. Now the bias circuit happens here, and you can see I've done some work here because these pins are still sticking out. I haven't trimmed them. The Marshall JTM 30 has a very interesting bias circuit. It is a fixed bias circuit. It is not a cathode biased amp like I thought it was at the beginning of this video. And what it has is, those pins that are sticking up right now, the bias circuit here is coming off the high tension lead off of this power transformer. What's actually happening with this power transformer is there is no center tap, there is no lower voltage bias tap coming off. Despite the fact you got all these pins here, there is no low voltage bias tap coming off this amp or this transformer. So what happens is that you got your high tension coming in 300 and some odd volts, and then it goes through this bias circuit here. So underneath you, I don't know if you can see in there. Okay, there's a series of diodes, Zener Diodes. Okay, those are giving you voltage regulation on how many volts negative voltage is going to the bias circuit. Okay, the diode before it is a normal Schottky diode, and it's providing your reverse polarity because it's taking the AC voltage and it's only giving you the negative side. Okay, and then there are there's a resistor that's a dropping resistor, and then there are two capacitors. One of them is your basic electrolytic cap, which I changed. I think it's a 10 microfarad 100 volt. I changed that, still getting issues with the bias circuit. One of the issues I found, which led me to this next problem, was when I flicked the standby switch, my bias voltage went from negative 49 volts down to negative 21 volts, which makes the bias run crazy on these power tubes. Now here is where I found the problem. In here, I don't know if we can see this. Maybe I should shine a torch in here. Bear with me for a moment. Okay, you can see the electrolytic cap there, but see to the left of it, there's that little grey box. Okay, just in between this resistor. So right there, that grey box is what's called an X-series capacitor. Now that capacitor is in series with the bias circuitry going through there, and what that capacitor is doing is it's not just a smoothing cap. It's an X-series cap. What that means is that an X-series cap, my understanding of an X-series cap, is that it is providing voltage regulation. Now that capacitor was the capacitor that was causing me the voltage drop, taking my negative 49 volts and dropping it down to negative 21. As soon as I replaced that cap, and it's the one with the long lead sticking out, that cap made everything better again. So finally got down to the bottom of this very unusual bias circuit that can catch you off guard. Now, admittedly, what I ultimately ended up doing was the scatter approach and replacing all the bias circuitry. I've replaced 3 Zener Diodes, and here are some of the replacements. Okay, now these are quarter watt ones that I mistakenly bought. I ended up replacing them. The ones that are in here now are 1 watt ones. Okay, and I replaced those. I replaced the Zener Diodes, the Schottky diode, the electrolytic cap, and eventually, finally got to the bottom of it, I replaced that X-series cap, and now the amp is working beautifully. The last thing I'm going to do while I've got this board out is I'm going to get in here, and there's a lot of flux around the solder joints where the 5881s sit, and obviously these amps are notorious for heating up, and people have put fan mods and all that. Now, speaking of mods, what I've done with the Zener diodes that I put in here, now as that truck goes by, the Zener diodes in here are regulating that negative voltage from the bias supply. What those Zener diodes are doing is that there's, by default with this amplifier from the factory, there are two 15-volt Zener diodes and one 9-volt Zener diode. So you're getting negative 39 volts on the bias. Now this is, while it's an unusual way to do it, it is a nice way of doing it if you don't have a bias supply coming from your transformer. So they've saved a few bucks, quite a few bucks, on not having a bias tap coming off the transformer. And they've spent a few cents on putting in this circuitry here. So, you know, Marshall's done a nice thing about saving money here, and in all honesty, electrical wise, it's a good bias circuit that's going to keep that bias supply pretty much bang on 39 volts. Problem is, at 39 or negative 39 volts DC, it's still running these tubes too damn hot, which is why these amps are notorious for burning up. The mod I've done, very simple mod, is I used three 15 Zener diodes, 15 volt Zener diodes, giving me a voltage drop of minus 45 volts. Now you're saying, well, that's only a minus 6 volts difference, but in bias terms, that is a massive percentage. And it's allowed these tubes to run still fairly warm, but the bias right now is sitting at about, according to my calculations, about 75%. And not 90% where it was before. Now this has become a very long rant because I believe this is vital and so important about this amplifier. These amps are notorious, they have a reputation, running hot, causing all sorts of issues. People put fans in them and muck around with all that stuff. You can drop the bias down a few volts and still have an amp that works just fine. It's not going to hurt the sound. It's actually going to make it better. Valves work best when they're biased correctly. Next time you see this amp, it'll be all put back together, and I'm going to give it a bit of a test run before I call the customer up, just to heat soak it and let it run for an hour or two, monitoring the bias, monitoring the condition of the valves, watching for red plating, and I can finally get it off the bench. Stay tuned. The amp's going to get assembled in a moment once I've reflowed these solder joints and done some other things. And we're going to hear this amp working. Alright, ladies and gentlemen, here's the Marshall JTM 30 in all its glory. I've had it soak testing for about an hour, and I've just got it on a clean channel right now. Obviously I can't play single-handedly. So right now the EQ is all in the middle. I'll switch to the gain channel in a second, but here's the volume. So that's the volume on 30 channel. Here's the master volume over here. And you can hear that gets quite loud. It's probably distorting the microphone. Reverb works. Sorry about the lack of playing. So you can hear the reverbs working beautifully there. That's all the way up. Sorry, I'll try that again. So that's no reverb. And here's with reverb all the way up. So, not a massive reverb. These things were never known to have a huge amount of reverb. Now let's go to the dirty channel. So, you can hear that's pretty good. Back to the clean channel. Dirty channel. Clean channel. Dirty channel. So you can hear that's working fine. Reverb's working. Send and return I'm going to test out right now. What I'm going to do is just plug the amp into the return. Sorry, plug the guitar into the return. I'll do that off camera. You get the idea. Anyway, so there you have it. Sorry about the dodgy camera work at the end there. But basically, there's your JTM 30 all working. customer will be very pleased when I ring him right now and tell him that it's all working and it's happy. It's been on my workbench for quite a number of months, just to troubleshooting, and also I have been on tour back and forth and things like that. So that about wraps it up for this video, guys. Thanks everyone for watching. Please don't forget to subscribe if you have a moment. Click the subscribe button down below. And yeah, it'll be great if you could share this video with friends who might be having the same issues or whatever. Let me know. Send me a message or post a comment down below, and I'm more than happy to explain what we're doing here and how we got the amp working nicely. So on that note, thanks everyone again, and keep watching more of my videos. Bye-bye.